Hi, my name is Ryan Fukui, and this is my final project for ITM 431. I'm just gonna go through those 12 interview questions from the prompts, and I found that I remember what the CISSP format really well when I use like images or analogies. So that's pretty much what I did for my project overall. First, first is this roadmap. So we got 7 sections right here: foundations, network design, protocols, security, behavior, troubleshooting, and advance. And these just go over that's 12 questions in total. So let's start from foundations. Okay, first, the OSI model. The easiest way I can explain this one or that I researched was that it's like a 7-floor postal building. Your message starts at the top of the building as just regular text, like to a text to a friend. And then it takes an elevator down that building, and every floor it does a little has a different job. Like one adds an puts an address on the message. One figures out the route. One chops it into smaller pieces, or in networking, it's packets. And at the bottom floor, it sends out the electrical signal. On the other side, the elevator goes back up, and every floor undoes its part. So the OSI model goes back and forth. And by the time it reaches the top, your friend sees that regular message, and that's it, the 7 floors, 7 jobs. It's pretty easy to understand the OSI model, just from this analogy that I found online, actually, so which is really good. The next the next question, question two, is OSI versus TCP IP. So if OSI is that 7-floor story building, TCP is more like a 4-story building or a 4-story version of that building that people actually use to build real networks. Um, it's the same building basically, but some floors are put together because they don't really need to be separated. OSI is what we learned in class. TCP/IP is actually what's used on the internet more often, or it's what the internet actually runs on. So when an engineer is talking about the application layer, they're almost always talking about the TCP TCP/IP model and not the OSI model. Um, so for question three, designing a small business network, I think of it more of like utilities in a building. The ISP is the water main out on the street, and the modem is the meter. It takes the street signal and turns it into something the building can use. And the router is the breaker panel. It controls who gets internet, and it also keeps the bad stuff out of the internet, out of the network. The switch is basically a hallway with doors in every room, and it's how wired traffic gets in and out. Oh, it gets going. And the wireless access point in the wall outlet for all the stuff without cables. So 5 pieces, and that's just a basic business network. Next, two more pieces that keep the network running is the DHCP. It's like the front desk at a hotel. Every device walks up, gets handed to a room key, which is the IP address, and it goes off to use it. You never really have to set this up manually. And the DNS is the phone book of the internet. You type in google.com because it's, easy to remember, but the computer needs something or an actual number to remember it by. It would be too take up too much storage if it goes based off of those website names. So DNS, yeah, just does that lookup for you every single time you go into a website. Next, TCP versus UDP. TCP, yeah. So there are two different ways to send data through the internet, and they're really, really different. TCP is like certified mail. You sign it, everything gets tracked, and if something gets lost, it gets resent. That's what we use for web pages, emails, banking, anywhere you need every single piece to show up. And it's important for security reasons as well as reliability. On the other hand, UDP is more like flyers being tossed off of a moving truck. So it's fast, but there's no confirmation and no resending, which sounds really bad, but it's actually perfect for, video calls, gaming, and as we learned in class, streaming. Because if you're on like a Zoom, you don't want a frame from 3 seconds ago to just happen right now. Next, we're going to talk about the TCP handshake. Um, and basically, the TCP starts every conversation. It's like a three-way handshake. So think of it like a polite phone call. Your laptop says SYN, basically, hey, can you hear me? The server says SYNACK, which is, yeah, can you hear me? And then your laptop says ACK, which is, yep, let's talk. Only after these three of those does the real data start moving, where that's where TCP's reliability comes in. And this is also really good for reliability, just so that the other side acknowledges, the other side. Next, for question five, HTTP versus HTTPS. The easiest way that I thought of it is HTTP is like a postcard. Anyone who handles it on the way can read anything on it, and HTTPS is a sealed envelope. The postcard can still move around, but they can't see what's inside that envelope. And that's why every real website today uses HTTPS because it's more secure. Like your bank, your email, all of those things that you use every day. If you ever see a site that has plain HTTP, that's usually seen as a problem, and there might be also vulnerabilities in that kind of website. So what's actually sealing that envelope that we talked about in the last one for HTTPS? It's called TLS, which is Transport Layer Security. And basically, when you connect to a site, your browser and the server quickly agree on a secret code, and then it talks about that code the whole time. Underneath, there's two kinds of encryptions. Um, Symmetric is one shared key, like you're giving your roommate a copy of your house key. It's fast, but you have to hand off the key safely first. Asymmetric, on the other hand, is two keys, one public key, which anyone can use to lock the box, and one private one that only you have to open that box. In real life, TLS is uses both. Asymmetric first to safely share that key, then symmetric to keep things, moving faster and more efficiently. Next, question six, NAT, which stands for Network Address Translation. Um, it's basically imagine an apartment building with one street address, but a bunch of apartments inside. When the mail shows up at the front desk, clerk look at the apartment number and sends it to the right unit. That clerk is NAT. The router takes all the private addresses inside your network. And translate them into a public address, um, one public address your ISP gave you. And it keeps track of who asked for what, so replies go to the right device. I think this is also the same analogy we used in class, which really helped me understand NAT extremely fast. Question seven asks us to go a little deeper on DHCP. Earlier I said it's like checking into a hotel, but here's the real, the full scenario. It's called DORA. Your device goes discover, anyone here? I need an address. The server then goes offer, here's one. Your device then goes request, cool, I'll take it. And then finally your server goes ACK, done, it's yours. And that's DORA. All in less than a second, and along with the IP, you get a subnet mask, a default gateway, and a DNS server address. So four things every time, and it's extremely quick. These things happen very fast. Next, so DNS records. So if DNS is the phone book, as we talked about earlier, these are the different kinds of pages. The most common is the A record. That's a name pointing to IP version 4 address. So this is the same thing, but for AAAA is the same thing, but for IP version 6, which is the newer one. MX is for mail, and it tells you which server handles email for that domain. CNAME is an alias, and one name pointing to another. TXT is for notes, usually used to prove your own domain. And NS records, say, which DNS servers are in charge. When you type in URL, your browsers flip through these pages to find the right IP address. When DNS fails, what happens? Everyone says that the internet goes down, but technically it really doesn't. and your connection is fine. It's like your phone still works. You just don't have the phone book anymore. If you happen to memorize Google's IP addresses, you could still get there, but nobody really does that. So the second DNS goes down and websites won't load, email stops working, and it feels like everything is broken even though the wires are totally fine. So now, what do you check when the internet isn't working? I like to think about it as rings working outwards from me. So first, is it just the one advice? Try the Wi-Fi on your phone. Does that work? The network is fine. Um, Maybe then it's just your laptop. Second, does the device even think it's connected? Toggle Wi-Fi on and off, replug cable. Third, are the router lights normal? Power cycle, the router and the modem. Fourth, you can also ping an IP address, but names might not be working. So that means it's a DNS. Try switching to 8.8.8.8. And fifth, if none of that even helps, check the ISP outage map. If the whole neighborhood is out, then there's nothing you can really do. So this is just ways you can troubleshoot if the internet's not working. Even with your personal device at home. Um, Businesses usually have teams that work on these things. Um, and but it's easy for you to troubleshoot as well. So question 10 is Wi-Fi problems. And I think Wi-Fi is like talking in a noisy room. Four things usually go wrong. You might just be too far away, move closer and get an extender. There might be interference, microwaves, baby monitors, thick walls. So you can move the router or switch to 5 gigahertz. The channel might be jammed because every neighbor is on it. So you can change the channel in your router settings, or just one device is being weird. So if you can just forget the network on that device and rejoin or update its drivers. A lot of this also from personal experience is that it's on 2.4 gigahertz, which might be impacted by other devices in your house, as we talked about in class. So it might just be that you want to try switch to 5 gigahertz. And I found for myself that also helps a lot, especially when um you're in a place where, a lot of other devices are in it as well. So there might be conflicting or interferences. So now question 11 is layer two versus layer three. These are two different types of scales of getting stuff around. Layer two is inside one building, and it's like you're delivering a package to the right office, and you use the person's name on the door to find them. That name is the MAC address, so this comes with the device, and it's hard coded into every device. Um, the thing doing the delivery is a switch. So layer three is shipping a package across the country, and you need a switch city zip code, and that's the IP address. And the thing doing the delivery is the router. So switches handle the traffic inside one network, and routers handle the traffic between networks. And lastly, the VPN versus public Wi-Fi. I think this one's really important as well, especially for us that we're using our computers all over the place. So public Wi-Fi is like a crowded cafe, and anyone in the room can potentially listen on in your conversation, and the owner of the network can see every site you visit. You don't really know if the network you join is really the real one. Which is dangerous for security. So a VPN basically wraps your whole connection in an encrypted tunnel to a trusted server. The cafe can still see the traffic going out, but they can't see what's coming in. And it's just looks like random noise. So pretty much anytime I'm on a Wi-Fi I don't own, it's really important that I use a VPN to ensure that my computer is safe and secure. And in closing, that's the end of my project. The biggest thing I would say I took away from this class is um, the best answer in an interview isn't the one that's the most technically worded, but it's the one that people actually understand. And in the class, we talk about analogies a lot, and you provide analogies in pretty much every class. So I try to make as many analogies as possible, either going on the internet, which I did for most of these analogies, or I just went on AI and see like, can you explain to me this concept because I don't understand it, and make it simple as possible. And honestly, most of the time they usually use analogies, but in this presentation, I also wanted to use a lot of visuals as well because visuals also help remembering, especially for the CISSP. Thank you.